Hi everyone, this is the second video for section 7-1, and we are continuing on page 208. So we already talked about classifying polynomials, finding standard form, leading coefficient, all that stuff. Now we're going to do some operations on polynomials. So operations just means add, subtract, multiply, or divide. In 7-1, we are going to add and subtract. So if we look at on page 208, we're going to look at number 13 first. So this is a polynomial right there. Negative 4x plus 9, that's a binomial. 6x minus 14 is a binomial. So we are adding two binomials. So the first thing you want to check is when you have addition, you don't have to do any distributing. Really, what you're distributing is a positive 1, but when you multiply by a 1, that doesn't change anything. So for these, the first step I want you to do is just rewrite them without the parentheses. You can do this for addition. Now, what we want to do is combine like terms. So like terms, remember, are the same variable, so x and x, raised to the same power, or exponent. So x, both of these x's have a power of 1, so those are like terms, we can combine them. So I like to identify my like terms like this. I'm going to circle both of those because those I'm going to combine. These, what I call plain old numbers, which are really constant terms, those are like terms, and I'm going to combine those. So now let's just go ahead and combine like terms. Negative 4 plus 6 is 2. So 2x, don't forget the x. And then my constant terms are positive 9 minus 14, that's negative 5. So there we go. I have found the sum. I have simplified and found the sum. Let's look at 16. This one's a little bit messier. 3 terms, trinomial plus trinomial. So always when you're doing these, first check to see what operation you're doing. If you're doing plus, then say, okay, I can rewrite this without the parentheses. So I'm just copying everything exactly as I see it without parentheses. Okay, now I got a lot of like terms in this one. I'm just going to start from the left, and I'm going to say, okay, a t to the second power. Do I have another t to the second power? This is t to the third power. That is not a like term. Constant, not a like term. Aha! Here is a like term, t to the second power. When you circle this, make sure you take the sign in front of it. Belongs to that too. Keep going. Do I have any other t to the second powers? No. Okay, I'm good. Now let's see what other kind of terms I have. I have a t to the third power, so I'm going to say, okay, I'm going to give these guys a square. Do I have another t to the third power? This is a t to the first power. Haha, here's a t to the third power. Notice when I identified that one with my square, I took that minus into the square. So when I combine these, I know this is positive and this is negative. All right, keep going. This is a plain old constant. I'm just going to give that a squiggly underline. I don't have any other constant terms, but I still have this who I haven't classified. That's a t with an exponent of 1. I'm just going to put an arrow under that. So I have to now combine my circles, combine my squares. These two don't have anybody to combine with, but they're still part of my problem, so I'm just going to put those on the end. So t to the second power plus 2t to the second power. 2 plus 1 is 3. So I have 3 t's to the second power. So we're just combining. If this is 2t squared sitting over here and there's another t squared sitting over here, we're going to put them all in the same pile. 3t to the second power. Now, here I have 3 t's to the third power. And over here, I have minus 2t to the third power. We already identified those as like terms. So now I just need to add the coefficients. 3 minus 2 is positive 1. So I'm going to have plus 1t to the third power. Okay, keep going. I have my negative 3 here, gave it a squiggly underline. There's nothing else with a squiggly underline, so just copy that negative 3. Keep going. I already took care of my circles. This is the last term I haven't done anything with yet, the one I put an arrow under. So stick that guy on the end, 7t to the first power. All right, so I have completed addition, but the next thing I need to do is put this polynomial in standard form. So now that we've learned standard form, we need to do standard form every time. And remember, standard form means my term with the biggest exponent needs to come first. So I'm going to do this term first, exponent of 3, exponent of 2, this term's going to come next, exponent of 1, this term's going to come third, and the constant is going to come last. So it's the same thing we did up here on these examples. So put this guy in standard form. 3 is my biggest exponent, so that's going to go in front, 1t to the third. Notice I'm not looking at these numbers. I'm not putting this 7 in front. I don't care about the coefficient. I'm looking at exponents. T to the third goes first. T to the second goes next. So plus 3t to the second power. T to the third power goes, first power goes third, plus 7t to the first power. Remember, I don't need to write that exponent. And then constant hangs on the end, I always say. So the constant is hanging off the end. Now I've done addition and I've written it in standard form. Okay, subtraction is a lot the same, except we're going to add a step. So got binomial, binomial. What do I have between them? I have a subtraction. So for subtraction, you want to slow down. We have to add a step. Remember, subtraction is the same as having a negative 1 out in front of our parentheses that we have to distribute. So I want you to write in the negative 1, and I want you to write in those arrows. So I'm distributing negative 1. Just back here. Notice I don't have anything happening up here. So this is just happening behind the subtraction sign. The stuff up front, just copy that. So everything in front of the subtraction sign is a copy job. Notice I left my parentheses behind. Now I'm going to distribute the negative 1, and when I do that, I'm going to leave my parentheses behind because I've done my multiplication. Negative 1 times 7 is negative 7. Don't forget the h. So just write negative 7h. This negative becomes a subtraction down here if you want to think about it that way. Negative 1 times positive 6. Positive times a negative is a negative, so this is going to become negative 6. Okay, so a couple of things here. First, check for subtraction. If you have subtraction, put that 1 and put your little arrows that remind you to do distributive property. This only happens behind the subtraction sign. Nothing changed up here. I just copied them. Okay, now I still haven't subtracted. All I've done is distribute the negative. That's what we call that. We call that distribute the negative. Share that negative with everybody behind it, not in front of it. Now let's combine like terms. I got an h and an h with an exponent of 1. Add the coefficients. Negative plus a negative is a bigger negative, negative 12h. And I have a constant and a constant. Again, negative plus a negative is a bigger negative. 2 plus 6 is 8. So negative 12h minus 8. That's already in standard form because my variable with a power of 1 is first and my constant is second. Okay, let's look at one of these messier ones. Okay, I'm adding some polynomials here, a trinomial plus a trinomial. Ooh, I see a subtraction symbol. Slow down, write the 1, and this time we have to distribute that negative 1 to 3 terms. Again, we're only distributing to the polynomial that comes after the subtraction. So I'm distributing the negative to this whole polynomial. The polynomial in front, just do a copy job on that guy. Don't change anything. Just copy it without your parentheses. Now we're going to do our multiplication. Negative 1 times 5 is negative 5, k to the third. Negative 1 times 7 is negative 7k. Negative 1 times negative 3, ooh, careful. Negative times a negative, positive 3k to the second power. If you're paying attention here, you might notice that distributing a negative just takes all of the signs inside the parentheses and switches them. Positive 5 became negative. Positive 7 became negative. Negative 3 became positive. It doesn't make them all negative. It makes them the opposite sign that they were. So multiplying and dividing by negative 1, that's what it does. Switches the sign. Okay, now we got to combine like terms. I got a k to the second power. I'm going to give that a circle. And then I'm going to check. Oop, here's another k to the second power. So I'm going to say those are going to be like terms. I'm going to combine those in a second. K to the third power. I'm going to put a square around that. Do I have another k to the third power? There it is. Again, when you're identifying these like terms, include the sign that's in front of it. This is a constant term. It doesn't look like I have another one of those. Squiggly underline. Maybe you want to do a triangle, whatever you want. And then this is a k to the first power. That's also the only one of those I have. I'm just going to put an arrow under that guy. Okay, let's combine our circles. 1k to the second power plus 3k to the second power gets me 4k's to the second power. 6k to the third minus 5k to the third. 6 minus 5 is 1k to the third. Remember, you don't need to write that 1. Invisible 1k to the third. Squiggly underline, I only have one of those, so copy that negative 4. I already took care of that. I took care of my circles. I took care of my squares, squiggly underline. Next one was an arrow. No other arrows, so nothing to combine that with. So do a copy on that. Now don't stop. This is not in standard form because this term has the biggest exponent, so the k to the third has to come first. K to the second comes next, so plus 4k to the second. K to the first comes next. This is minus 7k to the first. That negative belongs to that 7. Bring it with it. And then the constant hangs off the end, has no variable, minus 4. Okay, what I would like you to do is pause the video and try this one. 15 and 19. So pause the video and try 15 and 19. And then I'm going to have you try those, and then I'm going to maybe have you check those. Nah, I won't have you check them in class. You've already paused it. You've tried them. I will put the answer down here quickly. So for this one, you should have gotten 9x plus 1. And for this one, you should have gotten 2x squared and plus x and plus 3. I think that's right. I did that pretty quick. This would become positive, positive, positive. So 2x squared plus x plus 3. Yep, that looks good. Okay, that's it for 7-1.